quick question. How many of you have heard of Carp? All right. That's actually more than I expected, but it's good that I still have an audience. Disclaimer, I rewrote all my slides yesterday evening, so if my rhetoric suffers, that might be because, well, I rewrote everything. It's an entirely different talk now, but it's fine. The way I'm going to structure this is I'm going to explain what Carp is, then I'm going to show you a brief code snippets just to give you a feel. Then I'm going to do a quick live coding demo, just something really, really simple. And then I tie it back into Clojure and talk a bit about, well, how similar are they? Because while they look similar, they might be more different than we make it seem. All right. As is customary, I'm going to start by saying who I am. I'm the CTO of Port Zero, a small consultancy in Berlin, and I'm the Carp standard library maintainer, meaning I think a lot of about APIs, and I program a lot of APIs. I program a lot of the standard things like the testing library, the benchmarking libraries, vectors, sockets, which aren't part of the standard library yet, but all that kind of stuff. All right. So what is Carp? Carp is a Lisp 1. For those of you who still care whether it's a Lisp 1 or a Lisp 2, I don't know whether many of you even know what the difference is. So a Lisp 1 is something where functions and variables are in the same namespace. Lisp 2 is functions have a different namespace. That was more important back when Scheme and Common Lisp were the big guys in the Lisp room. And one of them was a Lisp 1, and one of them was a Lisp 2. Nowadays, most Lisps that come out are Lisp 1s. It's type inferred, it's borrow checked, it compiles to C, and it's made for real-time applications. Depending on your background, type inferred and borrow checked might not mean much to you. So the way to think about it is that type inferred means that it's statically typed at no extra charge, and borrow checked means no garbage collection without extra charge. Without extra charge means you don't have to do anything about it, or mostly. For type inference, you can, of course, annotate your functions if you want, but you don't have to. The goal is we figure everything out ourselves. And both of these concepts aren't new. So the type inference that we do is based on Haskells, and the borrow checking we do is based on Rust. So Haskell implements a Hindley-Milner type system, which is a very fancy word, but it's actually very straightforward, and it's very powerful. And that just means you don't have to spell your types out. And Rust implements borrow checking, which means you don't have to manually manage memory, but you also don't have a GC. It just figures out the lifetimes of values, meaning where they are still used, where they're alive, and once they aren't, it inserts a destructor, or it frees the memory there. Carp puts these things together, adds some Lisp macros, adds a good CFFI, and it also simplifies both of these concepts. Partly, that is because we're a small team of enthusiasts. We don't have the time or the resources to implement all of Haskell or all of Rust. But also, we try to make it as simple as possible first, try to figure out what we can leave out while still making it usable and a joy to use, and see whether we can get away with it. We probably won't. We probably have to add more stuff in the future, but for now, it's good enough. OK, let's look at some code. So ignore the 2 comment lines on the top there. Basically, what you see there is the definition of a function f. That's kind of like, it kind of looks like Clojure if you squint. It takes 3 arguments, x, y, and z. And what it returns is a copy, that's what the add is for, of the nth element of x, so x is obviously an array then, of the product of y and z, which then must be integers. Sorry, that's the index of the element then. And if you type that into REPL and then type f or :tf, you get back this, which is almost a type annotation as you could use it in code, which just says, this is a function that takes in a reference to an array of a, whatever a is, so any array that has this type variable, 2 ints, and it returns an a, which makes sense because an array of a we're trying to access, and what will be returned is, of course, of the same type, the array type. How you define types, that's how. I think most of you might know what an associative array is. It's basically a hash map implemented as a list where you have pairs and you look up things linearly. But what we're doing here is introducing type variables. So A and B are type variables that tell us, OK, I'm going to use 2 generic types. And in my definition of that struct, which has one member, LST, we have an array of pairs that use these 2 types. So it can be any type. So while I said the type system is like Haskell's before, actually it's closer to OCaml at the moment, but that's mostly because we haven't implemented any of the more, advanced features. All right. So I'm going to code some, and I hope you're going to enjoy what I'm doing. What I'm going to be doing, I wrote a little library that is based on processing, or not based on processing. It is a re-implementation of processing using SDL, which we have bindings for, and it's called Anima. And what we're doing here is just we load the Anima file. We use the namespace, or the module, rather. We define variables. We define an empty setup function. The draw function just draws a background. And then we say def sketch, which is a macro. All right. If I type CR, this is going to compile and run. And as is expected, we get a window with a grayish background. All right. So now I'm going to just add some things. The goal of this isn't that you understand what I'm doing, but more that you see the development workflow that you have. So I'm going to set the color to 200. So color and background both take either 1, 3, or 4 values from 0 to 255. If 1, then it's a grayscale value. If 3, it's an RGB value. If 4, it's an RGBA value. OK, so we're going to draw a line next. And we're going to say, OK, I want a random x between, excuse my typing, I'm very slow. But so a random value. And what's interesting here is that random between is actually an interface. So maybe it can figure out how the correct type. But in this case, it won't, because there's actually the same function, more or less, defined in the integer module. So when I do this, I'm getting an error. Several exact matches for interface lookup symbol, random between of type int to int. That isn't super helpful. But if I run it not in my editor, I will get this error that says int random between or anima random between are the 2 things that we could choose. And for now, we're just going to say, OK, take the anima version. Try it out. Works. So what happens now is, I don't know, yeah, you can see that. It's just jumping around lines. So there, we render a lot of frames a second, but we don't want that, right? I'm going to fix that in a second, but first, let's draw some more lines. So we just introduce a for loop, right? Oops. We introduce a for loop, do draw again. And this is what this looks like. Let's reduce the frame rate. We just do that in the setup function. Frame rate of 1. If I run this, it should be a bit nicer to look at. OK, now we can see what's going on. These lines, by the way, all end on a line from in the middle that goes from 0, 0 to 800, 800, because what I'm saying here is draw a line from xy to xx, which means this is always going to end up on a line in the middle, which is why they all look like this. And that's good enough, I guess, but we can do better than that. We can, make this a bit prettier. Oops, what did I do here? That's not what I wanted. Right. I'm going to just introduce this margin thing that I inconspicuously put in the skeleton. And if I now do this, then it's going to be pretty. And that's the final version. And that was simple. That's easy. But that's what Carp is made for. Carp is made for mostly interactive things, graphical things, games, because what we just did was write a program without types that's statically typed, and it also happens to not be garbage collected. So if I say frame rate of 1, it's going to be as close to 1 as possible per second, because there's no GC pause. The only thing that's going to hinder us from that is, say, the operating system telling my thread to sleep or whatever. So that's kind of nice. But we're at a Clojure conference, and so we need to look at Carp and Clojure and compare the two. So I'm not going to say that Carp or Clojure are better or worse, because they're just different. They look the same, but they don't feel the same to develop at all. For one, you have a statically typed versus a dynamically typed language. One is compiled, one is kind of compiled, meaning it is compiled, but it compiles to JVM bytecode or JavaScript, depending what backend you use, which feels a bit different as well. One works with C, whereas the other works with Java and JS. And that's really where the most similar thing happens. So the way we treat our host system, in our case, native, in Carp's case. In Clojure's case, it's the JVM. What we do is we abstract over to C or Java. We write wrappers, and then when we have those wrappers, we can have something that feels more fun, which is Lisp. And then there are some, on the language level, there are some differences. You have modules versus namespaces, which might sound like it's the same thing, but it also, again, feels different. You have compile time metaprogramming versus full metaprogramming, which means one is truly a Lisp, namely Clojure, and the other one feels like a Lisp, but at runtime, you can do quote, you can do eval, you can do car, coulter, cons, or head, tail, conj. You can't do these things because in a statically typed language, this is extremely hard to type. If not, I'm not aware, so I'm not advanced enough in typing to know whether someone actually implemented that, but it sounds to me that this is extremely hard to do. And then, of course, you have interfaces versus protocols, where interfaces are like generic functions in Haskell that get specialized. You can say, I introduce a function called equals, which takes A and returns a bool. Ooh. And you can do that, but then you have to specialize and have to say, OK, for integers, this function looks like that, and so on. Whereas in Clojure, you have protocols where you define that on a more, you define that with a more Java-y way, where you have an abstract type with protocols and stuff. OK, so the caveats of this is that Carp is early-stage software. We're a small community of people We have super few packages, and on a good day, we're 3 maintainers. On a bad day, we're 2. We have insufficient documentation, which is mostly my fault, because I maintain the standard library. It may change under your feet, and it may blow up in your face, especially now because we're fixing up the first stable release, 0.3, where there's a lot of stuff coming in, a lot of stuff being changed, and right now is not a good time to start your startup on Carp, or, you know. If you do tell me. I'm going to tell you that that's a bad idea, and you're a bad person to do that kind of stuff, but I want to hear it, because it's also kind of awesome. And I guess that's all I have. So thank you, and I think I have enough time for questions.
Yes, you do. So, questions. This is a difficult one. Panu or Juhana?
Do you do type checking after or during macro expansion?
That's a good one. I wanted to actually say that, but I didn't end up saying it, did I? The macro system is untyped, which that's why we can do the meta-programming part, because at the macro expansion time, you still have just symbols, and you have lists, and that's all fine. We don't know about anything yet. Then the macros get expanded, then the type checking happens, and we do some work to make it a bit more friendly with the error messages, because it kind of is hard to do error messages once you've expanded the macro. They're not as informative. So we link back to the old objects and all of that and keep that in state, and you still know where you did the mistake and not where the macro expanded and blew up, and you have no idea what kind of code this is, right?
Okay. I'm a little bit clueless about borrow checking, and it seems to me to make it very hard to make applicative data structures or persistent data structures that share parts, like lists that share their tail or something like that. So how does that work in Carp? And if it doesn't, who in their right mind would make a Lisp with borrow checking?
So. It doesn't. We don't have any of the fun data structures that you have. We have other data structures. We have so most of our more advanced data structures so arrays are still in the core, but for instance, maps are just a reader macro, and it's all a library inside Carp, so it's written in Carp. Same for like heaps and all kinds of other data structures. So the way I would describe, or why we do that, is basically, I think Eric said something to me. Eric is the person who invented it and who works on the compiler primarily, where I work on the standard library and do some compiler fixes when I find something. So Eric said to me, it's basically Rust that looks like Lisp and has some of Lisp's capabilities that are cool. But other than that, it's not really a Lisp. It doesn't feel like a Lisp, to me anyway.
Any more? Yeah. If you have questions, you can join this line here for the next round.
Hi, thanks. That was a nice presentation, and I'd love to try out Carp. But why should I try Carp and not Rust? So do you have kind of a story for that, or?
Right. So it has a bunch of things that Rust doesn't have. It has the macros. It has the global type inference, whereas Rust does it, but for variables, right? Which is that's simple to do. What's harder is to infer functions, which we can do. I think at the moment, if you want to just try out a borrow-checked language, that is, or a language with Rust's memory semantics or whatever, use Rust. If you want to try something that's a little bit different and that's interesting for other kinds of stuff, so what I just said was the media application. So we have, while we don't have much packages, we have OpenGL, GLFW, we have SDL and everything wrapped, and you can use those. And you have the animation framework, which is kind of a toy, but fun to use. So for game development, say, or any kind of interesting media stuff, it's definitely a good language to watch. Maybe not to use in production, but to try out, give feedback, make it a good language, help make it a language that you would actually use. That's the thing.
So you mentioned earlier that you use modules rather than namespaces. So are these like ML-style modules? Do you have things like functors as well?
No. So the difference in modules and namespaces is a bit... I should probably just have shown a module to exemplify things. But the way there's two ways to write a module. First, if you want to encapsulate functionality, of course, in a package. But also, what happens if you define a type is that it also opens a module that is named after the type, that has the type constructor in it, and getters and setters and update functions. Update functions are setters that take a function that updates the structure. But once you've opened that module, you can then extend it, which is the same syntax as if you open it for the first time. But the way this works is you have basically extensible namespace. So you can extend any module at any time, meaning that if I want to extend int, float, or whatever number double that I have, I just open the module at these new functions. So for the hash map, for instance, we open all of the standard library modules and just add a hash function to make the hash map work. Right? So this is kind of the difference, and this is kind of how this works, or what the idea behind it is. Does that clarify?